Right. uh, Electric field electric field due to spheres shells. Okay. So right, what is a sphere? A sphere is, a 3D filled object. Okay, unless stated otherwise. Okay, unless stated otherwise, what do you think of a sphere as? A 3D filled object. Okay, it's like a sphere. Okay, and what is a shell? Shell is a hollow sphere. Okay, hollow sphere. Okay, fine.
Sir, can you
Now,
wait for 1 second?
yeah, Akshat, Opal, and Rohan videos on.
Sir, why can't we just consider this as one like dot at the center?
Dotted. Which one?
Like a sphere or a shell, we can just take it as a dot at the center,
For
right?
what purpose?
And then we can make the electric field around it.
Yeah, that's what we do. See now. So first we'll take the case of sphere. Okay, sphere is slightly complicated. Shell is very easy. So consider a sphere. Okay. Yes, Opal.
So when do you start this chapter?
When do you?
When did you start this chapter?
Like this is the last lecture of this chapter, but you will understand this. Okay.
Okay.
So consider a sphere of radius r. Radius r. Okay. When I say sphere, it is filled. Okay. Okay. Why forgot to mention two things. One thing is conducting sphere. Conducting means it is made of conductor. Okay, made of conductor. And non-conducting means made of insulator. Okay. Okay, so made of insulator. So see, I will call this NC. Okay, and this C. Okay, so when I say CS, I mean a conducting sphere. When I see a NCS, I mean a non-conducting sphere. Okay, this will be the short term which I'll be using. Okay, consider a sphere of radius r, and this is suppose non-conducting. Okay, non-conducting. NC. Okay, non-conducting means it is suppose it is made of wood. Okay, EG made of wood. Okay. Now what happens? See, this is my sphere. Okay, and it is filled, right? Because it is a sphere. One second. It is sphere,
So
and
your
this.
voice is breaking.
My voice is breaking.
And now it's okay. Yeah.
Okay. So it is filled. Filled sphere means, and it is given a charge q. Okay, consider a sphere of radius r given a charge q uniformly. Okay, what is the meaning of uniformly? Uniformly means it is like everywhere it is same. Okay, then we will talk of something called charge density. Charge density, or it is also called volume charge density. Volume charge density. Also, do you remember we talking of linear charge density and surface charge density?
Yes, sir.
Linear charge density in the case of rod, and surface charge density in the case of a plane, right? Last two classes we have done that. So here, see, the linear charge density is lambda, the surface charge density was sigma, and the volume charge density is rho. So this is linear, this is
So
surface,
can I ask a question?
yes, and this is volume. Okay, yes, rho is charge per unit volume. Yes, ask.
Sir, won't the charge be on the surface only?
No, it is, that's why I said I'll explain you. Okay, with ये non-conducting बोला ना.
Sure.
Okay, charge per unit volume. So see, what is the volume of this sphere if the radius is r? Okay, now Sai will talk to me for some time. What is the volume of this sphere? Sai, hello, can you hear me? Sai Shyam.
Yeah, so
you help me this. What is the volume of this sphere?
4 pi r, 4 by 3 pi r squared
Yes.
cube.
What is the charge total given? It is q, right?
Yeah,
So what is sorry, I have wrote, yeah, what is rho?
rho will be 4 by 3 pi r cube.
Charge per unit volume, right?
Yeah,
So total charge q divided by
q divided by
4 by 3 pi
cube.
r cube. It is also written 3q by 4 pi r cube. Okay,
Okay.
fine.
Yeah.
Now what we need is the question is asked, what is electric field? Find electric field at a distance r from center. Okay, from center. The distance r from center. So you will have three cases. Case 1, when r is less than r. Case 2, when r is equal to r. And case 3, when r is greater than r. Okay. Okay. So first is the easiest case is case number 3. Case number 3 is when your point is outside the sphere. Okay. Suppose you know this is your sphere of radius r, and your point is p, which is at a distance small r such that r is greater than r. Then it is very simple. It is very simple. If this distance is d, see this distance is d, sorry r, right? R. You will इसमें क्या करते हैं? Consider the whole sphere as a point charge or point charge, okay, at its center.
Wait, which case are we doing first?
I am doing this case first. So for this case, consider the whole sphere as a point charge at its center. That means this whole sphere charge q, you can consider this case to be exactly like a capital Q, which is at a distance, and point P as a distance r. So what will be the electric field at point P? What will be the electric field at point P? By Shyam. Electric field at point P.
So q, wait, it's equal charge, right?
It is capital Q charge is here at distance r from point P. What is the electric field at point P?
Q by r squared.
KQ, capital Q by small r
K
square. Okay.
by r squared.
Keep
Yeah.
in mind that this is important, that this r is small q. Okay.
Okay.
Now the second case, the first case, sorry, is a little bit complicated. So what do we say is that this is your sphere, and this is radius r. Okay, so this is radius r. And what do you need is electric field at a distance small r, which is less than r. So you complete this sphere, and you find out rather I do it here. Find out how much charge, how much portion of charge, I should say how much charge that small sphere encloses. Okay, how do we find that? See, the whole capital R sphere, the whole sphere carries a charge capital Q, right? So what is the charge carried by small r sphere? It is very see, the surface the mass, the charge density is equal, right? So therefore the q contained divided by 4 by 3 pi r cube must be equal to total q divided by 4 by 3 pi r cube, because both of them are equal to rho. Okay, now who does not understand this star mark logic?
So I didn't understand it.
Okay, see, suppose okay, imagine you have a ball, okay, some rubber ball, okay. Who asked this? Ritvik asked this.
No, I asked Sai.
I is too much information for me to figure out who is speaking.
No, it's
He
psi.
said psi.
Oh, size. See, imagine you have a rubber ball. Okay, it is filled rubber ball. Okay, filled rubber ball.
Okay.
Okay, and it is uniform density. It is uniform density. Now, if I ask you, if the total rubber ball radius is suppose 10 centimeter. Okay, radius is 10 centimeter. Okay,
Okay.
and its mass is total mass is 100 kg.
Okay.
If I ask you, so see the whole 10 centimeter ball, the 10 centimeter ball radius has a mass of 100 kg. Okay.
Yeah.
If I ask you, if I cut this ball in half, this part, iska mass kitna hoga?
50.
50. Okay. So what have you done? You have essentially saw that the volume becomes half, therefore the mass becomes half, right?
Yeah.
Now suppose if I ask you a question that, okay, I'm not taking, I cut this ball into a smaller ball of radius 5 centimeter. Okay.
Okay.
Then what is the mass of that smaller ball? If I, exclude everything outside, so you will say, you will find the proportion of volume, right? So what is
Yeah.
the 4 by 3 pi 5 cube divided by 4 by 3 pi 10 cube, right?
Yeah.
When you find it, it will become 5 cube by 10 cube. Okay.
Yeah.
It is 5 by 10 the whole cube. It is 1 by 2 the whole cube. It is 1 by 8. Okay.
Yeah.
Therefore, it is the small white ball is 1/8 the volume of the total ball,
Volume.
right?
Yeah.
Therefore white ball ka mass hoga 100 by 8 kg, right?
Yeah.
This is the same logic I'm using. I'm saying that, or I can write the same logic in this way, that 4 by 3, mass of the small ball divided by its volume is equal to mass of the big ball divided by the big ball volume, right?
Okay.
Because both of these ratios are actually equal to density of the ball, which is same whether you cut the ball or not.
Yeah.
Same way, I am saying the charge carried by the small sphere divided by its volume is equal to charge carried by the big sphere divided by its radius, and the ratio is equal to the charge density, because initially I have said that's a uniform given a charge uniformly. Okay.
Okay. Yeah. Thank you.
So, one second. Now, so I will be, oh, sorry, one second. Okay. Now, so therefore, what will be the charge? What will be the charge enclosed by the small charge? It will be Q in capital Q into R cube by R cube. Okay, this will be the charge enclosed by the small. Now, what is the electric field at this point? Electric field at this point will be very simply K into, you will consider this charge, the enclosed charge, to be at the center of the again sphere. Okay, and this charge won't matter. I will tell you why this charge won't matter later. The dotted charge, outside charge, does not matter. Electric, what is the K? Electric field K. Q कितना है इसमें? Q divide by what is the distance? R square. Okay, so you'll put this K. Q कितना है? Capital Q R cube by R cube R square. So it is K capital Q by R cube into R. Okay. Okay, or I will write like this: K capital Q by R square into R by R. This is a better form. Okay. Okay. This is E at point P inside. Understood? Okay, everyone.
Yes, sir.
Okay. Now the second case is not a different. You simply see, you can see that, both
Wait,
of
sir, can you
these.
scroll down 1 second?
Yes.
1 minute.
Uh,
Yeah.
okay, now I'm going to ask you, if third case may, if R becomes equal to R, if R becomes equal to R, then what is the answer? It will become the second case. For the second case, the answer will become K capital Q by capital R square, right? Understood? Yes, everyone?
Yes, sir.
And if R in the first case, if R becomes small r becomes equal to capital R, again you can see here, if you put small r is equal to capital R, again the answer is KQ by capital R square, right?
Yes, sir.
And people who are in math, I have already taught you function continuity chapter, right? So see, you will understand how I have written this. Okay, E, okay, E at point P is this function K capital Q by R square R by R if R is less than equal to R and it is equal to K Q by R square if R is greater than R. Do you understand this? And this function is continuous because when you put R is equal to R, both of these functions are same, right?
Yes,
When
sir.
it's equal to the same thing.
हाँ, तुम यहाँ पे ये इक्वालिटी का साइन यहाँ भी डाल सकते हो, तुम इसको हटा के यहाँ भी डाल सकते हो क्योंकि फंक्शन कंटिन्यूअस है. Okay.
Okay.
And also the next second thing is we will make a graph of E versus R. The graph will look like this. It is simple. See, E versus R. Okay. For R is equal to 0. See, till R, this is capital R value. So till R, you are following a straight line. Why? Because it is proportional to. So K capital Q by R square, R by R. It's a straight line, right, with respect to R. So it will go like this. Okay. At R is equal to 0, it is 0. Okay. R is equal to 0, E is 0, and the Y value will become K capital Q by R square. Because if you put R is equal to R here, then it becomes KQ by capital R square. Okay. And then after this, it is inversely proportional to R. So it goes like this. Okay. 1 by R square. Okay. Understood?
Yes, sir.
1 second. Okay. You make this graph. Okay, everyone. Okay. Hello, everyone. I'll show you something and then see this on a graph. So E is a function of, suppose some k by R square is a constant. So some constant, suppose 5 into x. Okay, 5 into x, and if capital E is equal to 5 divided by x square. Okay, so see like x square, x square. Okay, so see it like it will be like this. 5, 5 see, from here to here, it is this graph. From 0 to a, this is this graph. Okay. It is this graph, and after 0, it is like this. Okay, this is called a, you can say it is a parabolic decay. No, not parabolic. Hyperbolic curve. Okay, this is hyperbolic curve, and this is a linear curve. Okay, fine. Have you made the graph, everyone? Okay. You videos on, whoever has turned it off. Next thing is Next thing is see see what happens if it is a what happens if it is a so this was for a non-conducting sphere, right? If it is a conducting sphere, it becomes very easy. If it's a conducting sphere, conducting sphere means whatever charge you give, okay, whatever q is given to the sphere, it will arrive at the surface and get distributed uniformly. Okay, so it will get dispersed on the surface. Why does this happen? I'll tell you in the next chapter. Okay. See, why does this happen? I'll tell you next chapter. But if it is yeah, if there is a sphere, okay, filled sphere, and what you do is you put a charge. So if it's a conducting sphere, okay, metallic sphere, okay, metallic sphere, then every charge will arrive at the surface. So all charge arrives at the surface, okay. Q. Then of course the E inside, okay, E inside will be 0. Why? Because at any distance r, you will not have any charge enclosed, right? So E inside everywhere is 0, and E for outside or on the sphere, okay, or on the sphere, it is K capital Q by R square, okay, where R is distance of P from center of sphere. Okay, write it down.
What is it for inside?
Inside it is 0. Electric field inside is 0. Why? Because there is no charge enclosed, right? If you take a Gaussian surface, okay, and argue that the E at this point, E dot ds is equal to Q enclosed by epsilon naught, the Q enclosed is 0, right? Okay, Rohan.
Yeah.
And this is the same reason why above, when point was inside, we were only concerned about the charge which is enclosed by that radius, with a smaller radius, because of
Okay.
Gauss law. Okay. Okay. This is done. This is done. Shall I move forward? Ritvik, can you hear everything?
Yes.
Yes, sir.
Okay, we'll move forward. And the next is shells, right? Shells. Shell, it doesn't really, shell is very easy. Okay, shell is easy. Shell means it is, there is negligible thickness. This is the property of a shell, okay, negligible thickness. So a shell, therefore, because of negligible thickness, there is no inner and outer radius, okay? There is no inner and outer radius. There is no concept like this, okay, for a shell. That means if there is a shell, it is so thin that you will not say inner radius is R1, outer radius is R2, and then you start saying R1, R2 is greater than R1. No, you will not say this, okay? Okay, there is another geometry which has which has a thickness that is called the annular sphere. I think you please check it, okay, if this is correct or not. Okay, annular sphere has two different radiuses, so it is like, you can see, think of it like as an avocado without the seed, okay, because it has thickness. So there will be r1 and r2, and r2 will be greater than r1, okay. But a shell will not have such a concept, it is very thin, okay. So shell बहुत easy है. A shell of radius r is given a charge q, okay. Shell of radius r is given a charge q. Simply E inside is 0, okay. E on is k capital Q by r square, and E outside is k capital Q by small r square. Very same like a conducting sphere, okay. Same like conducting sphere. Okay. So for both, see the cases, the result is same. So E versus R for a conducting sphere or a shell, okay, or a shell. It doesn't matter whether shell is conducting or non-conducting. It's same. For a conducting sphere or a shell, the electric field versus R looks like this. With R is equal to R, till R is equal to R, it is 0. 0, okay. And for R greater than R, it is, okay. So it is K. And the Y value at this point is capital K. So the X coordinate, the coordinate of this point is capital R comma capital Q by R square. Okay. Okay. Now my question is for a you have written this. Write this quickly. So my question is for a non-conducting sphere, okay, for non-conducting sphere, at how many points, and also you have to find if how many, whatever number of points, also find their distance from center. At how many points electric field is equal to electric field at surface divided by 2, okay. And same capital Q, radius r, it's a non-conducting shell. At how many points, and you have to also find the distances of those points from the center. E is E surface by 2. It is simple. Find out this. found out E is equal to E surface by N.
So you're gonna explain?
Yeah. Anyone would like to answer? Like, should I explain the question itself?
No, the answer.
What do you
How
got
do you
to
get
answer
it?
is?
I don't know.
Okay. What do you think of? I mean, can you explain the question at least? Hmm? Rohan,
You have to prove that, right?
no, you have to find at how many points electric field.
Yeah, at how
So
much?
see this graph. Okay. What is electric field to the surface? It is k cube r square, right?
Yeah.
Yes. So this is the y value, right, of the electric field. The question is asking at how many points the electric field is equal to half of this y value, right? At how many points? 2 points, right?
2.
One inside and one outside, right? So see, what is the electric field at surface? It is equal to k capital Q by r square, right? And electric field, I mean, divide by 2. And what is electric field at any point? See, if it is inside, it is capital, k. क्या था inside तो क्या था? What was inside? Inside it was k capital Q by r cube into r, right? K capital Q by r cube into r is equal to k capital Q by r square into 2. Understood? And when you solve this, k cube gone, you will get r is equal to capital R by 2, which is pretty much obvious, right? Hello.
Yeah.
Yes. Because see, this was a linear distribution, right? So what is electric field at half the distance, r by 2, at r by 2? It is half the maximum value, right? Understood?
Yeah.
Okay. Now, now the second point is outside. Outside का electric field कितना होता है? K q by small r square is equal to this k q by capital R square into 2. So what will you get here? It will be equal to r is equal to r square. Sorry, 2r square, right? R square is equal to 2 R square. So R is equal to root 2 R. Okay, root 2 R. That is 1.414 approximately R. Okay, so which is 1.414 R. That means it was this point, right? So it is a total distance of 1.414, or it is also at a distance of 0.414 from the R from the center. Okay, from the surface. So there are 2 points. So one R is equal to capital R by 2, and one R is equal to 2R. At both of these points, the electric field is half of the electric field at the surface. If you don't understand, ask me, I'll explain again. Yes. Anyone? Okay.
Sir,
Yes.
I didn't get the part R square is equal to R square after that.
See, for the inside point, what is the electric field? It is this, no?
Right.
For the outside point, it is this, right?
Yeah.
So what I want to find at which inside point is the electric field half of the surface point. Okay.
Okay.
So I'll do KQ by capital R square into R. I want to find this R, right?
Yeah.
Is equal to what is the surface पे कितनी होती है electric? What is the electric field at the surface?
Uh, KQ by R square too.
Capital
Right.
R square, right?
Yeah.
Just solve it. You will get R is equal to half of this, right? Because it is asked in the question.
Yeah.
So you solve this, you will get R is equal to R by 2.
Yeah.
Okay. So this is for the inside point. For outside point, what is the electric field? It is KQ by small r square, right?
Yeah.
This is equal to half of KQ by capital R square.
Yeah.
Now, इसको solve करो, you will get R is equal to root 2R.
Oh, okay.
Okay.
Yeah.
Okay. 1 second. Okay. Now, what we'll do is next question is next question. Once again, let me see. So what we'll do is, I think theory of pura everything is over. Okay, there is one more thing remaining, which is small thing, which is dipole placed in external electric field. Okay, so write this dipole placed in external electric field. Okay, and give me 2 minutes break. Okay, I'll be back in 2 minutes. Yeah. So see, there is an external electric field. Okay, nice electric field. I said uniform. Oh, you have to write uniform. First uniform. Okay, uniform. Uniform means so it is same everywhere. Same everywhere. Okay? And a dipole. And a dipole is placed. Okay. So suppose this is the axis, and dipole is placed like this. Okay. So what is this? This is the dipole. This is the minus. This is the minus Q charge. This is the plus Q charge. Okay. And the center of the dipole is kept like this, so that it makes an angle theta with the electric field. Okay. So dipole, the dipole moment was from negative to positive charge, right? Do you guys remember? The dipole
Yes,
moment
sir.
P vector was
Yeah.
from negative to positive. Okay. So the P vector is like this in this case, and the E vector is like this, right? And they are making an angle theta. Now I will calculate what is the force on the dipole. Okay, the force on the dipole is like this. So it is simple. The plus Q will be the force in plus Q is QE, right? Because plus Q is placed in an electric field E. So it is like this. And on the minus Q it is like this. Yes or no? Do you have any question in this? The blue things which I made, these are the forces on the
Sir,
on
could
the
you
charge.
repeat?
I'm saying, see, if you place charge Q in an electric field E, it experiences a force QE, right? Have I
Yes,
told this before?
I don't know.
Oh, see, you write this, okay? If we place charge Q in external electric field E, external E, it experiences a force Q. Okay. So everyone understood that the positive charge will experience a force on the right side, and a negative charge will experience a force on the left side. Yeah.
Yeah, this is a dipole moment, right?
Dipole moment is this vector. Dipole moment is this vector. Okay. It is the orange vector. Okay. It is the orange vector. It has got nothing to do with what I'm explaining. The force on the charges. Okay. This is the charge plus Q. This is charge minus Q. The force must be like this, no?
Yeah.
Okay. So one force is towards the right on the dipole, one force is towards the left on the dipole. They are exactly opposite in nature, right? So what we write is the F net on the dipole, the F net on the dipole, okay? F net is 0, okay? Because then there is a QE like this force and there is a QE like this, so F net is 0. The next thing which we write is, oh, sorry. Next thing which we write is the torque on the dipole, okay? So see the torque on the dipole. If you take this as the center, you take this as the center, okay? The torque is the force into the perpendicular distance, okay, of the application. So see see this, the total distance is 2a, then this half distance is a, and if this is a, then this distance is a cos theta, and this distance is a sin theta. Okay, so the perpendicular distance is a sin theta. So this torque, sorry, this the QE, the positive charge to the force, it is trying to rotate the dipole in a clockwise fashion, right? Clockwise fashion, and the force on the negative charge is also trying to push rotate the dipole in a clockwise fashion. So the torque net is equal to tau 1 plus tau 2 and the torque due to 1 is QE force. What is torque? Torque क्या होता है? It is RF, right? Perpendicular distance F sin theta. Torque is distance into force. It is perpendicular distance into force. So what is the perpendicular distance? The force is QE, right? Force is QE, and the perpendicular distance is A sin theta. Okay, and the torque 2 is also same sign. So QE A sin theta. So what is the total torque? Tau net is equal to 2Q. I'll write 2AQ, then E, then sin theta. Okay. Okay. Okay, everyone.
Yes, sir.
And what is 2AQ? It is the P vector. What is E vector? And what is sin theta? Sin theta. Sorry, these are magnitudes of P and E and PE. So therefore, I'll write tau net and PE sin theta. I'll write as P cross E, because A cross B is mod A, mod B sin theta. And you can see also that if this is P vector, this is E vector, where will P cross E go into? In which direction will P cross E? Hello, please tell me this answer. Okay, in which direction P cross E will go? Akshat, you will tell this.
Which direction you want E cos theta, right?
I'm asking P is like that, E is like this. Okay,
Yeah.
in which direction P cross E will go?
P cross V.
P cross E.
P cross E.
Yes.
Not sure. I'm not sure about cross product.
देखा क्रॉस प्रोडक्ट नहीं आता ना 12th में फेल हो जाओगे.
क्या?
क्रॉस प्रोडक्ट नहीं आएगा क्लास 12th में फेल हो जाओगे. पहली बुक समझ में नहीं आएगी बिल्कुल.
I have to practice it.
Rupak, in which direction P cross E will go?
Yes, so P cross E. So is it so it's to the right? I mean, that angle.
Anushka, in which direction P cross E will go? You are muted, I think, or some whatever. Your voice is not coming.
So I'm not sure.
Not sure. Saksham.
Sir, downwards.
Anika.
Even I'm not sure.
Ritvik.
Sir, I don't know, sir.
Rohan.
So do you want it in like terms of?
1 second. Rohan.
It comes out of the plane, I think.
Or Suyash.
Comes out.
और कौन बचा? गर्व. गर्व. Aditi.
Upward?
Opal.
Sir, what happened just now? I went to fill my bottle.
Very good. See, P cross E, A cross B is given like this.
Wait, what's the question? What's the question?
Leave it. See my video, okay? This is P and this is E. P cross E is given like this. You do right hand, you take right hand. You start from P, you end at E and curl your fingers. The direction of thumb is giving you P cross E, okay? Okay. So P cross E in this case will be like this. Okay. Okay.
Yes, sir.
So yes, Rohan, you were correct, but it was going into the plane, not out of the plane.
Yeah, it's going in, not out.
Okay.
So what did you say?
Rohan, थोड़ा सा, what are you using, laptop?
Me?
Yeah.
Oh no, iPad.
Go back, stand.
Go back and stand.
I mean, are you using earphone or something like that? Headphone? No, no, no. Who is using a
Hold on.
speaker? Who is using a speaker? Rupak, are you using a speaker?
Yes, sir.
Go back and stand. Increase your volume, output volume. Open your right hand and left hand like S. Okay. Now,
Yes, sir.
no, you can make any acute angle. Okay, no need to make it straight. Acute angle.
Like this.
Acute angle, like parallel to the ground. Yeah, like this. Okay. Now, Anushka, you tell me, in which direction is the Rupak's right hand cross left hand going? Right hand cross left hand. In which direction it is going?
So upward.
Vertically up, right?
Yeah.
Passing through his head. And left hand cross right hand?
Down.
Hmm?
Vertically down.
Yeah, towards his feet. Okay. Everyone, is there anyone in the classroom who does not understood the question or the answer? Yeah, Rupak, you sit down. Everyone understood?
Sir, I didn't get how you did the right hand thumb thing.
Pardon?
I didn't get how you used the right hand thumb thing for the
Right
question.
hand thumb. Right hand thumb. Anushka, can you explain to her how? Right hand. Yes. You are muted.
Sorry. So like, can I show with my thumbs?
Yeah.
Okay. So if it's like from here, this vector to this vector, then you need to like curl your finger like that, and then wherever your like thumb is pointing. And then if it's this vector to this vector, then you curl your like thumb like this way, because it's going like this. There.
Aditi,
Yes, sir.
she was explaining you, not me.
Yes, sir. I got it. Thank you.
Okay. So have you written torque is P cross E? Hmm? So you write, whenever there is something, the F net, the F is zero. F is zero. That means it is called translation equilibrium. Okay. Translation equilibrium. Okay. But if torque net is not zero, it is not zero, right? So it is not rotational, not rotational equilibrium. Okay. Not rotational equilibrium. Okay. You have to understand that this, this, one second, this dipole, okay, dipole, sorry, see, when the dipole is minus q and plus q, it is straight in the line of electric field. Okay, in the line of electric field, then the force on this is like this, right? And the force on this is like this. So in this case, the torque is also zero. Torque is zero. Why? Because there is no rotation. There is no rotation tendency, right? Because both are like straight away pulled like this. But if the dipole is like this, it is at an angle. Okay, then the forces will be like this, and then it will come to. It will try to come in. So if the dipole is in orientation 2, it wants to come into orientation 1. Okay. So does everyone understand this? That when the dipole is in orientation 2, it wants to come into orientation 1.
Yes, sir.
Yes. And which is the maximum unstable orientation for the dipole? It is this. The maximum unstable orientation for the dipole is this, right? Plus q minus q. At this point, there is a maximum rotation effect. Okay. Understood? Okay. So
Yes.
so where at it, which configuration out of 1, 2, 3 is rotational equilibrium achieved for a dipole?
1.
1, right? Okay, and where it is rotational wise maximum unstable?
3.
3. Acha, in which position 1, 2 or 3 translational equilibrium is achieved?
2.
All 3.
Okay, also.
All 3. Okay, because all 3 the F net is 0. Okay, write this question and answer. Yeah. Now let us see the assignment. Okay, who has not yet submitted the assignment? Who?
Your one, the one you made, right?
The yeah, the one I made. You have done it, Akshat. Who has not
Yeah.
yet made submitted the assignment? Please. Everyone has done it. Suyash, are you saying something? I can't hear what you're trying to say. Hello. Okay, there is one more thing I want to discuss. That if the
this question at 4 left.
okay, fine. So yeah, there is one more thing. If the electric field is not uniform, it is not same everywhere. Then you see, then it is very obvious that the that if the electric field is not uniform, these forces will not be equal, right? Because this will be Q into E1 and this will be Q into E2 because E1 and E2 are not same, right? So
Yes.
the F net is also not 0. So the dipole will not be in translation equilibrium also. Okay. Rotation तो नहीं है, translation भी नहीं है equilibrium. Okay. Okay. Then there are some small concepts. I will take one more class for this. And then you will do this. You will do what? You will do the whole worksheet. Okay. You will do the whole worksheet, but you will do it till you write this. Okay, what are 48? Okay, 48. Okay, 48 and till 48. Okay, 33 tak already you have done, right? So you have to do till 48 and then you have to do this, right? 71. No, 72 from 72 70 to 73 70 to 73. And then you will do 90 no, leave it. That's it. Okay, that one the school assignment. Then you come to competitive assignment. This is the competitive assignment. Okay, you can easily find it in the classroom. Okay, this one, and in this one you have to do, yeah. So I think you have done till how which question of this is you have done till where approximately?
So I think like around like 24 and like 20.
24. Okay. So you do this, up you
So 22.
22. Okay. So you move forward from 22 and then you start doing all this. Okay, all this 45, 47, 40, everything. Okay, everything till here. If you see a word potential in a question, you don't do it. Like 51. Okay, Okay, don't do 51. And then yeah, you can do till 50. You can do till 50. Okay. So everyone
We
who
do
has
all
not,
of them till 50.
you already have done 22. Till 22.
Which one is this?
This is, see, if you go to electrostatics, I first, there is school assignment, competitive assignment, okay, document PDF, okay. And
Okay, the one we had already done.
yeah, okay. And if you go to school assignments, the school assignment, the first one, you have to do, I have told, you know, till how much, till I have told you today to do till
48.
48, right? 48.
Yeah.
48, and then some questions also I added extra 90.
Yes, 71.
Oh, and from the 33, want us to do now till 48.
Yes. Okay. Okay. And whoever has not given my previous work till 33 will have an extra class tomorrow morning. Okay, at 11. Okay. I will not need to call. I will check at 11 कौन class में नहीं है, and फिर I'll have a PTM with their parents if you don't come to the class at that time, and if you have not submitted. If you have submitted, no need to come. Okay, I will check tomorrow at 11 a.m.
Wait,
and I'll be there here.
what do you have to finish till?
If you have not submitted question number 33 tak, okay. If you have not submitted question number 33, I have already given this work, right? Yes, Akshat.
Yeah, like 1 week ago, like this class
Yes.
last
So
week.
if you have not done it, please come to class at 11 a.m. tomorrow. If you have done it, no need.
So the competitive one you said till question 55 or 50?
50. 50, half century. Okay.
Yeah, fine, sir.
Then also we have to come to class tomorrow at 11.
If you have not submitted till 33, you have to come to class.